Hello friends, welcome back. So today I am going to discuss this STM32 based NUCLEO board, and this block provides crisp information about STM32 NUCLEO L4R5ZI evaluation board. This is based on STM32 L4R5ZI MCU. So this MCU is most suitable for various wearable applications where very low power is required. The energy saving strength lies in the architecture and various power saving modes. So it can go as low as 33 nanoampere in shutdown mode and 125 nanoampere in standby mode, with 5 wake up pins in both cases. So even standby mode with RTC takes only 420 nanoampere. So the eval board under discussion in this block has a provision to check current using ammeter. So you need to remove jumper 5 and put ammeter there. So I will be covering this evaluation board, and I will be covering the tool required and getting started, and followed by the demo on this. And if we decode this particular part, so STM32 is basically ARM based 32-bit microcontroller, and in this particular case this Cortex M4, and L is the ultra low power, and 4R5 is basically the code for device subfamily. So we are using like 4R5 here, and other families, for example 4R7 has other features like LCD, TFTP, this Chrome GRC and all, and these features are there, DSI host and all that in for R9. And Z represents here the number of pins here, 144 pins, and that's why we called it many times NUCLEO 144. And I represent the 2 MB 2 megabyte flash memory, inbuilt flash memory, and this Z represent basically that other options of other devices where the 1 megabyte flash memory. So complete part number will have packaging and temperature range information as well. So if you are looking for that information, please refer to the ordering information in this particular device datasheet given in the reference sections below. So this is getting started for a low cost evaluation. We call it like ST call it NUCLEO L4R5ZI, that is printed on the bottom on basically top of this particular board. And this board has two parts. So please note that the feature supported of this board based on the MCU part number decoding given above. So for other board, if you are looking for LCD and all that, you have to have another kind of board. And like as I told you, one part is this and another part is this. So you will get the board which will have this particular part linked with this, but this is a PCB which can be one can cut it. And so if required, normally by default you can use it with the board itself. So if required to reduce the board size, then one can cut it. So let's see that what is this particular part. So this is that ST link part, that is for programming and debugging tool. This is basically the tool integrated with the board itself. So this board has this particular link board itself has this STMCU, and here are you can see some jumpers. So based on the jumpers, if these jumpers are there, then it will be debugging the onboard main MCU, that is this particular MCU, and that connection to our laptop through USB cable. Only this connection is needed, and one can use it to debug or program any other board. In that case, these jumpers has to be removed, and this connector has to be used for connecting that particular board, and that is based on based on the programming concept here. And another thing, for example, if you remove this board, so you have to make a provision for another power supply of the main board. Right now that particular board will take power supply from this particular USB port itself. So this works based on this serial wire debug concept. So SWD connector one has to be connect to another board if you are going to program another board, and that is that serial wire debug definition. It is an alternate 2-pin electrical interface that uses the same JTAG protocol. It uses the existing ground connection, and there are two signal SWDIO, that is the bidirectional, and SW clock signal is there, and based on the ARM CPU standard bidirectional wire protocol. So debug interface, ARM debug interface version 5. So this enables the debugger to become another AMBA bus master for access to the system memory and peripheral or debug registers. So this particular debug interface is part of this board, and both, as I told you, if these jumpers are on, then the functions enable onboard programming, these jumpers, and if these jumpers are off, removed, then it can be used to any external board using the SWD connector, which is the CN5 here. And this is the MCU part. So MCU part, here you can see by default unsoldered pin footprints for all the connections from MCU, and apart from that these connectors, and this is the MCU, and here you will see that provision of different power supply. As I told you that in case of if you cut that particular PCB, then you have to provide that another source of power through this connector, whether it is a B-in or it is I will discuss all the options, but the corresponding jumper has to be changed. And from this side, that USB for user purpose. Okay, so power supply options, so various power supply options it has, and that MCU has to work on 3.5 volt, and but there are two voltage regulators. So for achieving this particular 3.3 volt, so once you get that 5 volt, then that green LED indicate that it has as this particular MCU part is powered and 5 volt is available. Then it is the job of the regulator to convert 5 volt to 3.3 volt. So one can anyway use the ST-Link USB power, that will be 5 volt, and by default it is through the ST-Link, and ST-Link driver will should be in your laptop, and if you install that tool, any tool or driver, then that can be connected, and I will show you that tool also used with this particular board. Another option is that you can, suppose if you have already programmed this, you are just monitoring this or checking this, then you can always provide that USB charger also, because that purpose is just to provide the 5 volt to this particular part. And another external provisions, you can directly provide 3.3 volt, directly provide 5 volt, or you can even provide 7 volt to 12 volt at bin. So in that particular case, another regulator will convert this to 5 volt. So whatever decision you take based for this power supply, you have to change the corresponding jumper here. Okay, so that detail is given in the data sheet. And this geo connector, as I told you, these connectors known as the geo connectors. So these contains all the signals. For example, CN7 contains PWM, SPI, I2C, that is integrated inter IC sound bus related signals. CN8 contains SDMMC and WIN and reset related signals, and it contains CN9 contains this UART, and I2C can all the bus related, like serial audio interface related, CN10 timer, PWM, QSP, ADC. So ADC. So this basically provide the overview of features supported through these connectors, and any other connection is needed, then one can anyway use the Morpho connector. As I told you, this is the Morpho connector. So these two are like CN1 and C12, so all signal power pins to that. So these connectors can be used to connect STM32 NUCLEO board to an extension board, and these unsoldered by default pinpoints can be used as a test point. You can connect CRO or any other logic analyzer, anything to that. So that is the additional thing. Apart from that, you will see the numbering here, D0 to D13, D15, and this side A0, A1, A2, and power related numbering. So this particular part is Arduino compatible. So Arduino R3. So I can show you here Arduino R3 board. You can plug it, but at the same time just make sure that below that if it is not sorting anything. Another thing you have to be cautious about that bolt IOs of STM32 are 3.3 volt and Arduino 5 volt compatible. That is another point to note here. And there is a USB with micro AB for that user related thing that I already discussed. And let me go through that. So what we need just this particular board. So this is the complete board right now. You can see this is the first part, which can be which is cuttable, and this is the another part, that is that MCU part, and the above is the debugger part. And if if you don't need this Arduino, so anyway this Arduino will not be part of the board. So this is the separate thing, and you just need to connect your USB at this point. And assuming that this is the complete PCB with this particular part not cut, and in that case you can simply use this tool, True Studio for STM32 family. So in this block what I have described, like this is that free tool and Eclipse IDE based tool, and download link I provided below, and it's free, and and even can be used for commercial project, no license, easy to install, has all the required feature to start development in STM32 based devices It includes editor, compiler, linker, debugger, memory stack analyzer. It also supports advanced debugging features such as hard fault analysis and this trace and profiling, RTOS aware debugging. So free RTOS or anything can be used in this with this particular board also, I believe, or at least with this family of the board. And that download link I have provided, and target supported list of target supported link I have provided. So I did not find any issue installing this to my Windows 10 system. And creating project is pretty simple, similar to like any Eclipse IDE. You have to do file, new project, C project, then embedded C project. I will anyway show you this particular demo. Then select the target board, then select that software settings. I took the default one. Then select the ST link for debugging and right click, build the project and download the code. So first time when I connected, it provided me some warning, and that warning was to update the firmware of the board so that it can communicate with the latest driver. So I updated that, and that was also pretty simple. And after that I tried the debug, and it simply stopped there. And I'll show you the demo. And please subscribe to this Embedkari channel, YouTube channel, for any such information. So let me go to the Atomic, which is the ST now, and here I created some project, but let me show you. File, new, and C project, and here you have to embedded C, Atomic ARM, next, and I need to put some name here. Project name, and then this is the list of target. Basically it supports. In that I am interested in STM32 LE4 plus board. I need to choose. This is the NUCLEO L4R5ZI board I have, and I simply go next and take the default setting, and create the project for board debug and release, and just finish it. So basically this, after finishing, it takes some time to create this particular project. And once this project is finished, so I have to simply right click and build this, because all the linker, compiler, everything is part of this particular tool. And I don't need basically any external debugger, because I am using ST link. And so you can simply right click. I created, I think, this one, and build project, and then right click, debug as, embedded C, C++ application. Oh, which target? Okay, let me check it one more time. Sometime it, I believe, reset the board first time, then second time it should definitely work, and it says all the settings. Okay. So here you go, that like as other board, we can simply step in, step out, and we can see that particular registers, peripheral register, general purpose registers. So as usual, like any other Eclipse IDE based debugger. Okay, thanks for watching, and that's all for today's getting started.